At the end of meiosis 1, every daughter cell has 2 chromosome 1 chromatids, 2 chromosome 2 chromatids, and so on and so forth. The issue is that both of those chromatids for chromosome 1 will either be both maternal or both paternal. There's not the one from mommy, one from daddy anymore. So while these cells are viable, they can be maintained within the ovaries or the testes for a while, they are limited. Their version of interphase between meiosis 1 and meiosis 2 can be very short-lived, or can be a few hours, few days, few weeks, depending upon the cell, the person, the species, all that. What we do know is no matter how long this interphase point between meiosis 1 and meiosis 2 is, these two daughter cells will never enter into S phase again. Okay? End of meiosis 1, telophase, cytokinesis, splitting of the one cell into two. Those two cells at some point in time will then enter directly into meiosis 2. There might be a pause for a while, an abridged version of interphase, like I said, but there will never be an S phase again. The only S phase that will come into play with meiosis occurs before meiosis 1 starts. Now, when you look at meiosis 2, you will see meiosis 1 separated the homologous pairs. Meiosis 2 is all about separating the sister chromatids, so that you end up with 4 cells. Start with 1. Meiosis 1 gives you 2. Meiosis 2 will then give you 4. And since you only had one doubling going from haploid 2N to 4N before all of meiosis starts, logically that states that if you go through 2 divisions, the resulting 4 cells can only have 1N haploid. Meiosis 2, as I said, you take the 2 diploid daughter cells that resulted from meiosis 1 and you divide again. No S phase, no duplication of the chromosomes. You immediately go into meiosis 2. Meiosis 2, again, meta, ana, telophase, cytokinesis. During meiosis 1, as it's showing here, you separated the homologs. You ended up with some crossovers, as you see here, blue with red tips, red with blue tips. And then here, after meiosis 2, same machinery, same things set up and work at it again, just like we had with meiosis 1. You're separating the sister chromatids.